Life in the sea. Life in the sea is rich and varied, with organisms ranging from tiny plankton to massive whales. The ocean is home to various ecosystems such as coral reefs, deep-sea trenches, kelp forests, and open ocean habitats. Marine life includes fish, mollusks, crustaceans, marine mammals, whales, dolphins, seals, seabirds, and other creatures like jellyfish and squid. The ocean is also full of microscopic organisms like phytoplankton, which play a key role in Earth's oxygen production and carbon cycle. Different zones in the ocean host different types of life, with the surface waters being full of light and nutrients, and the deep sea being cold, dark, and under immense pressure. Life at extreme depths often exhibits fascinating adaptations, such as bioluminescence, glowing in the dark, and chemosynthesis, producing energy from chemicals instead of sunlight. What is seawater? Seawater is the water in oceans and seas made up of water, H2O, along with dissolved salts, mainly sodium chloride table salt, as well as other minerals and substances like magnesium, calcium, potassium, and bicarbonate. It is more saline than freshwater due to these dissolved salts, with the average salinity around 35 parts per thousand, 3.5% salt. Seawater also contains dissolved gases like oxygen, carbon dioxide, and nitrogen, essential for marine life. What is the temperature under the seabed? Beneath the seabed, temperatures can vary depending on location, depth, and geothermal activity. The temperature just below the seabed, called the sediment layer, is usually quite cold due to the surrounding deep ocean waters. In deeper layers closer to the Earth's crust, the temperature rises. Close to tectonic plate boundaries or volcanic areas, temperatures beneath the seabed can become extremely high. The geothermal gradient typically increases with depth, about 25 to 30 degrees Celsius per kilometer in the Earth's crust. But in some areas like near hydrothermal vents, temperatures can exceed 400 degrees Celsius. Are there volcanoes under the seabed? Yes, there are many volcanoes under the seabed, particularly along mid-ocean ridges and tectonic plate boundaries. These submarine volcanoes play a vital role in the formation of new oceanic crust. Some of the most famous underwater volcanic activity occurs at hydrothermal vents, which release mineral-rich, superheated water into the ocean. This environment supports unique ecosystems, with organisms like tube worms and certain types of bacteria that can live without sunlight, relying instead on chemosynthesis. How deep is the deep sea and how dangerous is it? The deep sea begins around 200 meters below the surface, beyond the reach of sunlight, and extends to the ocean floor, which can be as deep as 11 kilometers, nearly 7 miles, in areas like the Mariana Trench. The deepest part of the ocean, known as the Challenger Deep, is about 10,994 meters, 36,070 feet deep. The deep sea is extremely dangerous due to the high pressure, over 1,000 times atmospheric pressure at the surface, low temperatures, close to freezing, and complete darkness. These conditions make it one of the most extreme and least explored environments on Earth. Specialized equipment is needed to withstand the crushing pressure and freezing temperatures, and only a few human-piloted submersibles have reached the ocean's deepest points. What do people use to get to the bottom of the sea? To explore the deep ocean, people use advanced technology like submersibles, small, highly specialized submarines designed to handle the immense pressure of the deep sea. Famous submersibles include Alvin, used in Titanic exploration, and DSV limiting factor, used in the Mariana Trench. ROVs, remotely operated vehicles, unmanned robots that can be controlled from the surface, equipped with cameras, lights, and tools for research or collecting samples. AUVs, autonomous underwater vehicles. These are unmanned vehicles programmed to carry out preset tasks, such as mapping the ocean floor or monitoring marine environments. Deep diving suits. Pressure-resistant suits allow divers to go to greater depths, though they are limited compared to submersibles. Why do people want to do research on the seabed? There are several reasons scientists and researchers explore the seabed. Understanding Earth's history. Studying the seafloor reveals how Earth's geology and plate tectonics have shaped the planet over millions of years. Discovering new species. Many new species are discovered in the deep ocean, where life forms have adapted to extreme conditions. Exploring resources. The ocean floor contains valuable resources like minerals, oil and gas, and understanding their location and quantity can be important for future energy and materials needs. Climate change research. The ocean plays a major role in regulating Earth's climate by absorbing heat and carbon dioxide. Studying the seabed helps scientists understand long-term climate patterns and changes. Preserving biodiversity. Discovering and understanding the unique ecosystems of the deep sea is critical for conservation and biodiversity protection. Studying extreme environments. The unique conditions of the deep ocean are of interest for astrobiology and the study of life under extreme conditions, potentially offering insights into life on other planets or moons, such as Europa or Enceladus. The mysteries of the deep sea. Despite advances in technology, more than 80% of the ocean remains unexplored. The deep sea is one of the last frontiers on Earth, hiding mysteries of life, geology, and possibly even undiscovered species. The exploration of the deep sea is challenging, but also essential for understanding Earth's biosphere and environment.